Okay, we are going to prove the shortest distance from a point to a line. Our general formula of the line is ax plus by plus c equals 0. And the point is at A, x0, y0. And so here's the point, that's the line. And the shortest distance from the point to this line will be vertically to that line. And we have the intersection point at the B, and the distance we call it DAB. Again, because the intersection point is B with the coordinate M, comma, N, and then we know the slope of that vertical distance will be 1 over minus 1 of the slope of this that line. This line of slope is what? Minus A over B. So that means this vertical line of slope will be A over B, because these two slopes should multiply equal minus 1. And then this slope, we can also calculate this slope based on the formula of the slope as y minus n divided by x minus n, then equals A and B. And so notice this y 0 minus n, that's basically is the difference on the y-axis. So that would be the y now, and this will be what? N. So that will be the delta y. And similarly, x0 minus n, that basically is the x0 n. So that will be the delta x distance. So this is, now we have delta y divided by delta x equal b over a, and that's the slope of the vertical line, AB. Now, if we move this line as b delta x minus a delta y equals 0, and then we square them on both sides, and then we will have this a delta y minus b delta x squared equals 0. And we can expand this formula as follows. The first term square, second term square, and the product of the two terms with the minus 2 in front of it. And we can then move this intermediate term to the right-hand side, and then we will have a squared times delta y squared plus b squared times delta x squared equal the right-hand side. So, okay, so that's the one preparation based on the vertical line slope. And the second preparation, we try to find the simplification of this term. Notice this term is the a times delta x plus b delta y, and then we square them. So this is different from the top one, but we want to find a different form of this. And if we expand this form, we have the first term, second term, and also the middle term. Notice the middle term is basically 2ab delta x delta y. That basically is the term we found in the previous step. So we can replace this middle term with its equivalent on the left-hand side in the previous step. So after this replacement, and with some simplification, we have intuitively, this is quite interesting. So L A delta X plus B delta Y parentheses square equal to A square pi B square, and then times delta X square plus delta Y square. So this delta X delta Y is basically, so we basically found what delta X delta Y, that's delta X delta Y. So, and then we can find out this distance by calculating delta X delta Y. This is the motivation of that, why we have to find out the form of delta X delta Y. So, okay, so now because the point B m comma n is on the line ax plus by plus c equals 0. So we can put m and n into the formula, and that means we have m here and n here, and then we have a times n plus b times n equal minus c. So that's why we just put in the formula, we got this one. Now, once we have that term, let's calculate a times, let's calculate ax, a delta x plus b delta y, and we just put in the definition. Delta x is x0 minus n, and delta y is y0 minus n. So this is because so we have x now n and y now n. So that's the delta y, and this is delta x. So we have that. And then we can expand this, and then we have what? X plus b now minus this term minus an minus bn. And this is what? This is basically c. So we can just replace that minus c here. And then we have a x now, b, y now plus c. So what this term does is, that's basically is this term. Right? So a times delta x plus b delta y is equal to that. And then we can basically, based on these two equations, right? So there, this is that. And this is our distance square. Let's use the red. Distance square. So then we can, from this 1 and 2, we can find out the distance. So this is basically number 1, right-hand side. And this is number 1's left-hand side. And from number 2, we can show this term is equal to, this is based on equation 2. So, and then that's basically the distance squared. So then we have the distance squared AB equals ax0 plus by0 plus c squared divided by what? A squared plus b squared. So we have a distance AB equal A x now plus by now plus c. Now this could be a negative number, so we take the absolute value of that. And then divided by the square, the root of a squared b squared. So there, so we have found the formula for the shortest distance from a point to a line.